right. Hi, everyone. Who likes to wait on money from their friends? Although we probably not necessarily like it, for most of us, it's no big deal. And because, of course, we have limited amount of friends and money, at least I do. We lend money too. But imagine you are lending money to hundreds or thousands of people, and you need to keep track of the outstanding payments. All of those people are promising they will pay you back in the next 30 days. But of course, we can all imagine how that will end. I probably will have a lot of friends, but unfortunately, no money. Now, from a serious side, our plan today is to guide you through our DIY accounts receivable forecasting platform that helps us, our customers, manage our outstanding or your outstanding payments better. But before we dive into the details, let us introduce ourselves. So my name is Florian Sturm. I'm a co-founder of a Belgium-based company called Daedalo. And our mission is to democratize AI through our custom AI platform, especially built for our customers' needs.
And I'm Julie van Akkeren, a data scientist at Element 61. It's a Belgium-based company that focuses on data consulting at small, medium-sized enterprises in Belgium.
All right, before we jump into it, just a short outline of our presentation. So first of all, as both of our companies are driven by creating business value for our customers, let's start from a business perspective. What are we trying to solve? How are we solving it? And how can we validate results? And then look into the details, into the technical perspective on how we actually achieve this and how do we build a sustainable solution on the Databricks platform.
Indeed. So let's start with the business perspective. So we focus on accounts receivable forecasting. What is it? Well, we look at the outstanding invoices at our customers. We want to know who is going to pay late. Most of the companies have a very reactive approach. So if a customer is past his due date for payment, then we will contact the customer to pay his invoice. But it's a big issue because, of course, cash flow drives a business. So predicting when a customer is going to pay his invoice would be, of course, better because you can anticipate who is going to pay late. You know the cash flow in the foreseeable future, and you can move to a very proactive approach. And you can contact the customer on beforehand. So that's what we do. We go for a proactive approach. It's a very quick win because most companies have the history of their invoices, and it's the base of our model in predicting accounts receivable forecasting. You lower your credit risk, and also you can plan your expenses, your investments, and potential savings because you know your cash flow in the future. So go for a proactive approach, we say. Well, we show you an example. Let's say you're a production company in pharmaceuticals and you want to expand because it's really necessary and your business is growing. So you want to invest in more machines, for instance. Well, you need to know if the cash flow can actually cover your costs.
All right, but how do we approach it? As I mentioned in the beginning, we really want to focus on business value. So of course, if you want to focus on creating business value, you have to start at the beginning. You have to start with identifying the business problem. That is super important. Next to identifying the business problem, we also always nudge our customers to actually not only identify the business problem, but also already beforehand come up with a strategy on once you have results and what are you then doing with these results. That's actually super important to not create a proof of concept, build out a pilot, create a production model, machine learning model, and then afterwards looking at the results and thinking, okay, now I know what invoices are being paid, what are going to be the actions that I'm going to take on them. Our goal during our strategy is to, of course, provide immediate feedback or impact, have an efficient implementation, and not only in favor of our customers, but of course, also for ourselves, and because we're a SaaS platform company. So the more efficiently that we can deploy and reuse this solution to different customers, the more interesting it is for us as well, of course. And if needed, if the customer wants to take our solution and build on top of it, improve it using their feedback and their contact strategy, of course, it also has to be easily maintainable by our customers. A very important step, next to developing proof of concept, building out a production model, is actually the business validation. A data scientist or a team, we can create nice models, but if in the field the results are not as expected, of course, we're missing business value, and that's the whole point of the exercise. That's the whole point of using AI machine learning in your business processes. And then something that we, both our companies are valuing highly as well, is coaching the customer, and not only the data scientists, if there are data scientists in the team, but also the people using. So in our case, of course, we will be predicting outstanding invoices when those invoices will be paid. But some people have to act on it. So it's the people in the business, in the finance team, that need to act on nudging customers, that need to know how to act on it, how to interpret results, look at dashboards, get actionable insights to then go forward. Now, how do we look at data science? Today, we will give you an insight into the technical details, but for us, as mentioned, it's very important to provide easy maintainable code and to provide direct impact. So data science for us is not creating the latest, the fanciest machine learning model with all the whistles and bells to get to that 90 or 95% accuracy. But our goal is to create a solution that's maintainable, easy to understand, and that suits the business case best. Our motto is the easier, the better. Now, if we're translating those business requirements and our vision into a plug-and-play AI solution, what are then those requirements that our technical team needs to take into account? First of all, we want flexibility, but we also want automation. And so we're looking into automated infrastructure deployments. Secondly, feature engineering, the input of your model training, the whole base of your machine learning models. If possible, I would like to standardize it so that we can reuse it, that we also use a set of features that we know have proven value for other customers. And as predicting invoices, it's quite similar for companies across Belgium in our case. So standardized feature engineering. The training as well, it's not, it's one thing to create your base table with your standard set of features, but it's another thing to create an automated machine learning model based on the KPIs that you set to train them. Then fourthly, we have the automated machine learning lifecycle. During the keynote, we saw that it's regarding Gen AI, that 85% of companies are creating POCs, are training models. In our case, machine learning models, you train them yourself most of the time. But of course, when looking at driving business value, you have to also productionize these machine learning models. And ideally, you want to do it in an automated way so that regularly these models get updated using the latest trends, the latest data, updated by the context strategy that our customers or yourself have implemented to improve these invoices. And then lastly, and something that sometimes is overlooked at, monitoring. And not only from a technical perspective, to understand how our model is performing and to understand that the model that we have trained today is better than the model that we have trained 1 month ago, but also for the customer. And Julie will take you a bit more into business KPIs, because we believe that when building machine learning applications, you don't have to look only from a technical perspective into the technical KPIs, like accuracy of your model, like R2, R squared, importance when predicting for using a regression model. But we really believe that you have to look at the impact that the machine learning model is bringing to your business and using the results to change your business process. So step by step, looking into the details, as we're a European-based company, you will probably not be surprised that we're using Microsoft Azure as our cloud platform, where you can see it probably. We try to create it or to create a platform for a solution that is as simple as possible. And where on the one side you have your data sources, typically your ERP system, where SAP is one of the biggest, of course. Unfortunately, also a lot of Excels that are generated or that are used to keep track. And then we use Azure Data Factory, which is your ingestion tool where we can, for example, on a daily basis, get the latest status of the invoices, information of customers. We store it in a data lake, a Delta Lake in the Azure storage account. And then there we use Databricks to not only mingle with or transform the data during the data preparation, create the features, but also where we train our machine learning models, experiment with them, and also automate the machine learning lifecycle. All of this is orchestrated also by Data Factory. And of course, we're not deploying solutions in an unsafe manner. So we use separate environments where we have, or where each of our customers have their own virtual network and their own key or secret management tool, being Key Vault in our case. Now, how do we automate this setup? We do it using infrastructure as code, where we use Terraform, which is an open source framework to do this, where we deploy the infrastructure at Databricks, its factory storage account, the VNets, etc. can also be deployed through Terraform, and also the roles and the responsibilities of all the people that have access to the right data, people that can mingle with or tweak the machine learning models, etc. And we're doing it in two environments. And actually, on the right side of the slide, you can have, if you have no idea what Terraform is, there's a screenshot of it, where you can see that you have to declare some objects, and you see the variables, the parameters that you can actually reuse, and not only for yourself or for that one customer across different environments, but of course also across customers, which makes it super useful for the customer, but also for us, that we can automate that deployment. So thanks to Terraform, we can create these different environments with the same resources, but it doesn't stop there. So it doesn't stop with deploying the infrastructure in an automated way. Thanks to the CI/CD pipelines, we also, of course, would like to automate the functional code. So the code that is part of the Databricks notebook, the code that is part of Data Factory, that is orchestrating, that is ingesting the data. So therefore, we use Azure DevOps to use build and release pipelines, where during the build pipeline, what we actually do is we take the code of, for example, a Databricks notebook, and we package it into an artifact, and then that artifact gets picked up by the release pipeline, which then runs on a self-hosted agent to make sure that networking-wise you can access that isolated VNet, and in that way, that release pipeline is deploying the code of Data Factory of Databricks to the different environments. So concretely, how does it work? For those that know Databricks a little bit, there's two ways in which you can store your code, let's say. You have the repos, which we typically would advise to start coding in, not only for yourself, but also to work together with your team, where you can have a Git integration with DevOps in our case, but of course you also have options to connect to GitHub, where we would code on development branch, on feature branches when, for example, we get change requests from our customers, and then we would pull into main. And the same would apply for Data Factory, where, for example, if the customer has access or has managed to make it configure the firewall and give us access to another database or another on-premise data warehouse that we can use the data from, and then that would also, of course, be something that using a feature branch, for example, we would make those changes and then eventually pull into the main branch. Once pulled, and the scenario I already explained, we have the build and the release pipeline, and then very simply we go to the production environment where we have the Databricks workspace. So there are no connection anymore to the repos, but directly to the Databricks workspace, and then in Data Factory to the live mode. As an extra test, as part of the release pipeline, we also included some testing where if we deploy to the new environment, that a code run gets triggered to make sure that all of the changes that we made and that were validated in a development environment, that they of course also work in production before having the next batch process that gets triggered the next day. Next to these automated infra requirements or infra deployments, which was the first step, which we successfully checked, we of course also wanted to standardize feature engineering, where in a first step, and this is the mandatory data that you need, of course you need some invoicing data, because that's the whole point of this solution, that you're going to predict a number of days outstanding, etc., of invoices. So that's something that is mandatory. And a few examples of the features that might not be out of the box available directly from data source, but that you as data science team or machine learning engineer need to actually compute, prepare for the model to train itself on, is the year of the invoice that was created, the document type, but also the invoice amount, etc. Just all of the information that can have an impact. And there it's also interesting to talk with the business to learn how maybe they already have a view on, okay, how do some invoices change the behavior of our customers in the way they pay the invoices. Secondly, and from here it's an add-on. So the only thing that you really need is the invoice level features. Of course, adding additional information can be relevant. For example, at the customer aggregated features, and my paying behavior towards my friends might be different than Julie's paying behavior. So of course, it's all relevant information to also take into account. Some of those features, again, probably they're not pre-calculated as part of your data warehouse, but it's something that the data science team needs to take into account, or that they need to make work of it. The preferred payment date, the number of previous invoices, really the previous behavior of those customers. And then lastly, and this is quite an interesting one, I think, data collections. And this is the whole point of the solution as well. In the end, you're looking to improve a certain business process. And your end goal is to have your cash earlier available so that you can make investments sooner than later. So the goal of this solution is to get an insight into the paying behavior, but then of course also to act on it and to make sure that the paying behavior improves. And that information is also something that you want to take into account when training a model and when making a prediction in the future. For example, what action did we take to contact that customer? At which dunning level as well? Was it just a simple nudge, or did you really take up the phone and try to convince them through a phone call that they had to pay on time? Of course, this is the feature side, which is the crucial base table, as we like to call it, of any machine learning model. In this case, it looks a bit like this. But of course, we're trying to predict something, and the outcome of our results should be something in the case of regression model, where you would predict the number of days that you're late. But often, number of days that the customer will pay late is quite difficult to actually act upon. The difference between a customer paying after 28 days or 30 days, probably your contact strategy will not really differ. So that's why actually we often suggest to not, or we could do it both, but to also include a classification. And it can be both ways, right? You can do a regression and then use the regression output to create a classification and to develop your contact strategy based on those classifications. Or you can do it up front, that you immediately create a classification or that you use a classification algorithm to use or to create these boxes. To give you an example, if there's a customer that on day one that you send an invoice, you receive a notification that, okay, this customer has a bad track record. So probably we expect them to only pay the invoice after 60 days after the due date. you have to immediately take action, because otherwise you will need to wait for a long time on your money. Where do we store it? How do we store it? Probably no surprise, but we use Databricks, Unity Catalog to store the data, not only the data, but also the models. We use Delta tables, because why not? It's only advantages to use them. And in that way, we make sure that using the medallion structure, we have our bronze, silver, gold tables, where in bronze we have our raw data, and then we clean them up to gold. So in that way, we have 2 of the 5 initial requirements that we actually checked.
Indeed. So now we go over to the standardized ML training. Of course, we need to train a model, because otherwise we cannot predict the number of days that a customer is late. And we actually use AutoML. It's very nice in Databricks. Why not use it? Lots of people or companies use it for data exploration. Explore your data. Are there missing values? Looking at your base table, include certain features or not. And is there even a use case? So a lot of the time we use it as data exploration to look, okay, can we actually predict what we want to predict? But here you can. So we use it actually to put it also in production. So we use the AutoML to have the best model based on an R-squared, for instance. We mainly focus on the regression case, so the number of days late. But we also, as data scientists, iterate upon the features, because of course, in AutoML it works, but still you need to look at which features are important for my customer on the data, which not. Maybe you need to iterate upon it, leave some out, maybe change your periods, and so on. But it's very nice because you have an interface, you can put it in code, you can definitely use the base table because we stored it in Unity Catalog with Delta, so it's easier to use it like this. So that's the next point that is checked. And then we go over to the automated ML lifecycle. As most of you know, you have a great interface in Databricks. So you have the experiments, you have the model registry, you have even now service endpoints. You can even put your models into Unity Catalog, as we also showed that they showed today. So we use it as well. So we develop a lot on data. We put it in experiments and then we let it run, for instance, for a month. We pilot it a bit at our customers and we see, okay, is this a good model or not? And then we put it, of course, in production at our customers. We push it to the production environment as well. But of course, that's not the only thing we do. We actually focus on different KPIs because you probably in the future will retrain your model because you have new data on the features. And then we focus on a technical KPI, as Julian already said, or a business KPI. Because of course you take actions upon your customers if they pay late. So a technical KPI is great if you predict initially because you have your prediction, you have your actuals, your customer will be 40 days late, and eventually it is like that. So it's great to compare. But after a while, you will take actions and you will contact your customer on beforehand. So you predict that you will be 40 days late. Actually, your customer is on time now because you took action upon it. So the actuals and the predictions are far from one another. So a technical KPI is not really the way to go. You need to focus on the business KPI. Is my average number of days late decreasing? That's really important for the business itself. They don't know about technical KPI, we know it. So of course we need to track them both, look at the correlation with our actions, but a business KPI is often a very good way to also show your company or the company and the customers if the model works or not. So we focus definitely on the second scenario if we put a new model into production. So for instance, you have your old model, you have new data, you're retraining a model, you can actually let them shadow for one another for 1 week, a month, a longer period. And then eventually look at both models and look at the business KPI. Is one KPI better than the other? Is the number of days late less for the one model or not? If so, you can actually replace your current model, put it into production, and the old model can be archived, which is great. So we do it actually like this. And for the use case, and this gives a good overview, I think, of what we do. So the fourth point is checked as well. But of course, yeah, your customer doesn't know about the models, doesn't know about Databricks interface maybe. So they want actually a dashboard. And management wants to see, okay, what is my cash flow? Which customers do we need to contact or not? So in a good dashboard, which we usually do with Power BI, for instance, you can see then, okay, these are the invoices that are going to, that are paid late, for instance. You can see the future cash flow as well, and also an action list. Yeah, is it very severe? Will the customer be late a long time or not? So then the action needs to be more severe, for instance. But you can also compare to your investment, for instance, because that's another use case. But as developers, we also want to have insight in our data. So we actually track the technical KPI, we track the business KPI, and we look also at the versions of the models, and we compare it to the actions, because it could be that one action, like sending an email, doesn't impact the behavior of the customer over time. So then we say, okay, don't look at this anymore. It doesn't really affect your business KPI in the end. So dashboarding, very important for us. And for instance, this is an example. It's not real data because we can't show it from our customers, but it can look like this. For instance, that you see your amounts over time. You see the customers that are going to pay late and so on. So most of the time it looks like this. So we checked actually all 5 requirements to make it more efficient, to make it easy, make it maintainable, which is very important for us, and replace a better model over time.
Yes, perfect. So great, all requirements fulfilled. Here in the end, we have a view of our DevOps as well as our Azure environment, which is then our fully fledged solution that we built for our customers. Feel free to also use this for your personal finance, and your friends will probably have no excuse anymore to not pay you on time. Thanks a lot, and if you have questions, feel free to ask.